All right, hello and welcome. This is going to be our homework help video for the law of cosines homework. I'm only going to do two problems. I'm going to do problem number 1, and I'm going to do problem number 7. I've picked these problems because they have a lot of our concepts in them. They're going to take us a little while, and they both use the ambiguous case, and I'll talk about what that means. Let me get my pen to the right size. Start this video off with a sneeze. All right. So I know I have to use law of cosines in problem number 1 here because I've been given 3 side lengths. The only time I can use law of sines is if I have an angle in the opposite side, which is clearly not what I have here. Law of cosines, the formula itself uses all 3 side lengths and an angle. So if we ever have an angle and 2 side lengths, we can use it to solve for a 3rd side length. Or if we have 3 side lengths, we can use it to solve for an angle. Let's copy down our law of cosines. The main one is a squared equals b squared plus c squared minus 2bc cosine capital A. And we can swap this around to solve for either b squared or c squared. But I'll just leave it like this. I mean, we have to solve for all 3 angles anyway, so we'll start by solving for angle capital A. If this is capital A, then this is little a, this is little b, this is little c. Let's fill in the values that we have. A squared is now 14 squared, b squared is a 19 squared, c squared is going to be 9 squared minus 2 times 19 times 9 times cosine A. Start solving for this, we get this is 196 equals 361 plus 81 minus 2 times 19 times 9 is 342. Highly recommend you follow along in your calculator to get used to doing these operations. There's a lot of ways to make mistakes. All right, going to subtract 361, subtract 81 from both sides. These are all my like terms, so I want to get them together. Don't just try to combine all 3 of these numbers. We can't do that. This is being multiplied, so it can't be, this 342 cannot be combined with these 2 numbers over here. These are like terms with this 196, so that's why I'm combining all of them. 196 minus 361 minus 81 is a negative 246. Equals negative 342 cosine A. Divide both sides by negative 342. I get 0.71 equals cosine A. Inverse cosine, inverse cosine. And we get that A is equal to 44 degrees. So 44 degrees. Now, I don't know if I mentioned this, but solving a triangle means that we have to find all 3 angles and all 3 side lengths. We've got 1 down. But having that 1 now opens up the door to doing law of sines to find the others. I'm going to find angle C next. Sine of angle C divided by its opposite side 9 should be equal to the sine of 44 divided by its opposite side 14. Multiply 9 to both sides. I'm just going to write down the decimal here. Sine of C equals 9 times sine 44 divided by 14, 0.446, inverse sine to both sides. I'm just leaving those numbers in my calculator so I don't have to type them back in, and then just using the second answer to plug them back in. I get angle C is equal to 26.5 degrees. That looks about right, 26.5 degrees. And that is what the answer key says. Now, technically, when I did the inverse sine here, I also get the supplementary angle. Angle C could also have been 180 minus 26.5, 153.5 degrees. Now, it's clearly not. We can look at the diagram and see that that's clearly not 153.5. And also, after we solve for angle B, we'll know that it's definitely not 153.5. But this is the ambiguous case. We discard this answer as being extraneous. When we did this law of sines here, we only plugged in an angle and two non-included sides, and that opens up the opportunity to get two answers, and then you have to pick the one that's more reasonable. Here it was the 26.5, and that's also the one that your calculator gives you. Your calculator will always give you the smaller angle, the more acute angle, but watch out for when it could also be the more obtuse angle, and you have to subtract this one from 180. If you had tried to solve for angle B before solving for angle C, that would have happened because this one is obtuse. To find this one here, we can just do our triangle sum. All three angles should add up to be 180. So if I do 180 minus the two angles I already have, 44 and 26.5, I'll get our last angle, 180 minus 44 minus 26.5, as being 109.5. So 109.5 degrees. To avoid issues with the ambiguous case, just solve for the two acute angles first. You'll always have at least two acute angles, if not three. All right, number 7, though, forces us to deal with both of the cases in the ambiguous case. And so this is just all about drawing good triangles. We'll start with side length B. Side length B is 15. I'm just going to draw like a generic 15. Angle A is 35. So it's going to come over here. 35. And then side length A is 11. And you can tell, drawing this triangle, those three things match up. But that 11 could have swung in and hit that 35-degree angle here, or it could have swung out and hit it out here. So it's kind of all about drawing these triangles right to see the ambiguous case about why we can get two different triangles with those three measurements. But once you start doing the math, you'll get the numbers right anyway, even if your diagram's not perfect. Now to find area, I want to find this angle in between these two side lengths. In order to do that, I'm going to have to find this angle first because that's the one that law of sines enables me to find first. And then I'll be able to plug it into my area formula. So law of sines. The sine of 35 divided by its opposite side 11 should be equal to sine, we'll call this capital B. Sine of B divided by 15, multiply both sides by 15, times 15, sine 35 divided by 11, times 15, 0.78, sine of B, inverse sine of both sides, and we get that angle B is equal to 51.4 degrees. Now what I said is your calculator would always give you the more acute one, so it's giving you this one here, the 51.4. You can get this one by just taking its supplementary angle, 180 minus that, and we get 128.5 for the more obtuse case. That's going to give us different angles for this top angle, 180 minus 128.5 minus 35 is 16.5 for this one, and 180 minus 51.4 minus 35 equals a 93.6 degrees for this one. Let's plug them into our area formula. 1/2 times the two side lengths times sine of the included angle. Plug that whole thing into your calculator. 0.5 times 15 times 11 times sine of 16.5. We get 23.4 square inches for this one. And then over here, this is very similar, except for the angle is different. 1/2, 15, 11, sine of 93.6. 0.5 times 15 times 11 times the sine of 93.6 gets us 82.3 square inches for this one. All right, so as long as you remember that when you do law of sines, you get this angle and its supplementary angle, you'll be able to just set the problem up in the two different ways, even if you can't get the diagram perfect. We call that good for this video. Good luck with the rest of your studying.